A supercar made in China can be sold for 20 million RMB, equivalent to $3 million US. When you first hear this, wouldn't you find it incredible? But if I tell you this car is made by BYD, moreover, it is limited to only 30 units worldwide. With such scarce quotas, top tycoons in the Middle East snapped up 22 units directly. Only 3 units were left for China itself. It can be said that one car is hard to come by. Wealthy circles are scrambling to buy it. In the past, the global top-tier supercar circle only recognized the luxury attribute of European century-old fuel vehicle brands, whose racing heritage firmly monopolized the market, but now international consumers come all the way to China to place orders for cars. Chinese supercars have officially stepped into the ranks of the world's top supercars. It is none other than BYD's Yangwang U9 X. Why does this car have such a fatal appeal? First and foremost, it has defeated the Bugatti Veyron, which has dominated the fastest supercar category for nearly a decade and a half. It boasts a combined maximum power of 3,019 horsepower. With 4 motors driving 4 wheels independently, its top speed can reach 496.22 kilometers per h/hour. Officially certified by the German ATP test track, it has claimed the top spot in the global top speed rankings. This pure electric supercar from China has directly rewritten the industry benchmark for global top speed in international professional racing venues. It is worth noting that Bugatti spent 5 years on repeated tuning and extreme optimization for its supersport model, yet its top speed only capped at 490 kilometers per h/hour, whereas the Yangwang U9 X easily surpasses it with just a press of the accelerator. It has opened up a gap of nearly 6 kilometers per h/hour. What terrifying performance is this? As the speed approaches 400 kilometers per h/hour, air resistance surges exponentially in a square law manner. Every 1 kilometer per h/hour increase in speed requires overcoming exponentially increasing wind resistance, increasing the speed from 490 kilometers per h to 496 kilometers per h. Though it seems like a mere 6 kilometers per h difference, it actually means breaking through the limits with great effort. Wind resistance, air pressure, and the stability of the car body hugging the ground form 3 physical barriers. This cannot be achieved simply by stacking horsepower. Instead, it relies on the ultimate optimization of the vehicle's aerodynamics, downforce, and chassis attitude control. Only by taking all these to the extreme can we barely break through the boundary of human speed. This is the hardcore strength of the Yangwang U9X. It doesn't rely on sentiment. It only depends on its hard power, with overall performance superior to peer models. You might think that the top speed is its full capability, but that is a narrow perspective. The same car, right after challenging the top speed, went on to conquer the Nürburgring Nordschleife, known as the Green Hell. This devilish track features 20.8 kilometers and 177 consecutive corners, where the Yangwang U9X clocked an officially certified lap time of 6 minutes, 59.157 seconds, becoming the world's first mass-produced pure electric supercar to break the 7-minute mark. It dominates in straight-line top speed and outperforms peers in cornering performance. It truly achieves all-round excellence with no weaknesses. Century-old fuel supercars have long been stuck in a dilemma. Top speed and handling are inherently conflicting. If you want to maximize straight-line speed, you will inevitably lose control in corners. If you want stable cornering posture, forget about extreme top speed. Back in the day, Bugatti, with its top-tier speed heritage, spent years honing on the Nürburgring. Yet, its final lap time was only 7 minutes, 40 seconds. The Yangwang U9X roams freely on the track, being more than 40 seconds faster, and leaving Bugatti behind by several kilometers in track mileage. How does it achieve such a dimensionality-reducing strike? The core lies in 2 sets of core black technologies independently developed in China, which have shattered the century-old industry shackles. The first is the e-Power four-wheel drive independent four-wheel drive architecture. Four motors are matched to four wheels respectively, delivering 3,019 horsepower across the entire speed range. A true, strong player never relies on simply stacking parameters. The core of its superior overall performance over peers is millisecond level intelligent electronic control. A single motor can reach a maximum speed of 30,000 revolutions per minute, and the torque of the four wheels is intelligently and dynamically distributed over 100 times per second. In an instant when cornering, the inner wheels automatically reduce power, while the outer wheels supplement power in real time, like an invisible giant hand firmly locking the car body in place. Traditional fuel supercars rely on outdated mechanical differentials. Even a slight deviation in steering will lead to either oversteer and loss of control, or understeer and deviation. For the Yangwang U9X, all these handling flaws have been completely eliminated by self-developed algorithms. The second is the YunNian fully active intelligent suspension system. It has long exceeded the scope of ordinary suspensions, equivalent to installing 4 intelligent mechanical legs on the car body that can adjust height, hardness, and softness at any time. When starting, it automatically lowers the car body to reduce wind resistance for extreme acceleration. When cornering, the outer suspensions actively support the car body to suppress roll when passing through bumpy roads. It smooths out vibration peaks in milliseconds. The single-axis lifting speed reaches 500 millimeters per second, with a maximum adjustment stroke of 75 millimeters per second. The four wheels sense and adjust independently and collaborate in linkage. Ordinary suspensions can only passively withstand bumps, while YunNian actively predicts and controls the vehicle's posture. The independent torque regulation of the four wheels, combined with the intelligent posture coordination of the four suspensions, these two core Chinese technologies are intricately intertwined, which is the confidence that makes traditional global supercars fall silent for the Yangwang U9X. However, for any supercar, no matter how powerful the horsepower is, without solving the heat dissipation problem, it is just paper data. Motor performance degradation at high temperatures has always been a fatal pain point for pure electric supercars, and this is exactly the ace trump card of the Yangwang U9X. It is equipped with the world's first mass-produced full domain 1200V ultra high voltage platform, outperforming the mainstream 800V architecture in the industry. With higher voltage, it unleashes stronger power at the same current, while significantly reducing overall heat loss of the machine. Coupled with BYD's self-developed silicon carbide SiC power modules, even under high-temperature working conditions of 200 degrees Celsius, the conductivity efficiency remains stably above 95%. What is even more hardcore is that the core chips are neither purchased externally nor customized. They are selected from the company's own production line, picking the top configurations. It achieves full industrial chain vertical integration, being the only one of its kind globally, with exclusive customization. A high-flow oil pump plus a three-dimensional integrated cooling solution has increased the overall performance of the cooling system by 133%. The four motors are equipped with independent oil cooling channels, and the battery pack adopts a double-layer water-cooled plate structure, setting an unbeatable industry benchmark for heat dissipation. But no matter how fast it runs, it is useless if it can't stop. Absolutely useless. The braking configuration of the Yangwang U9X is also top tier. It is equipped with titanium alloy high-performance calipers, matched with carbon ceramic drilled brake discs, at a top speed of 300 kilometers per hour. The braking distance is only about 110 meters. The tires are exclusively customized by Yangwang in cooperation with Giddy Tire, using a semi-hot melt formula. With the core made of aramid fiber, the same material used in bulletproof vests, the safety redundancy has directly exceeded the top speed standard of 500 kilometers per hour. The Yangwang U9X has never been outstanding in a single performance aspect. Instead, it excels in high voltage platform power output, heat dissipation, temperature control, braking, tires, and intelligent electronic control, with no weaknesses in the entire chain from start to finish. There is no weak point. Decades ago, fuel supercars relied on large displacement mechanical stacking for performance. In the new era, flagship pure electric supercars compete in systems engineering and cutting-edge materials science. The two are no longer in the same competitive dimension. What capital fears is never the limited sales volume of 30 units, but the technological barriers built by BYD, century-old European automakers have long relied on brand premium to make easy money. But this era is being completely overturned and rewritten by Chinese technology. Now, the Yangwang U9 X redefines the calling card of Chinese manufacturing. It can still reach the global peak of performance and define the ultimate standard of the industry. This is never just a story of a supercar breaking through. Instead, it marks a turning point of an era. The Chinese automobile industry has completely achieved overtaking on the curve, leading the world. If you were given 20 million yuan, would you choose the Yangwang U9X or traditional supercars like Ferrari and Bugatti? Let's discuss it together in the comments section.